Okay guys, so I don't usually record myself talking because my voice is bad and I'm generally bad at recorded things in general. But the other option this time was typing out in Minecraft my entire 5-page video as a script, so here we go. Hello my fellow aeronautical engineers and infrastructure enthusiasts. Today I present to you a highly useful airship docking complex that is modular, tileable, and can be configured for a large range of airship sizes. Additionally, this design was specifically made without the use of any wireless redstone links for better reliability on multiplayer servers where there are many other people using up a plethora of encoded wireless channels for their own bases, farms, contraptions, and more. Over here, I have moved the docking configuration inputs to this floating platform using wireless links solely for the sake of demonstration. In real applications, you can simply position the control room to the side of the logic circuit in view of all the panels. Now, without further ado, let us begin our fantastic journey of exploring airship docking solutions. In only a few decades, the heavily anticipated Create add-on Create Aeronautics will be released, bringing with it an entirely new revolutionary age of transportation. The introduction of airships as a primary form of transportation presents itself a deceptively simple problem. Where do I park? A seemingly easy enough question to answer, but let us walk down the incredibly long path of thought that resulted in this efficient docking system. The first solution that an enthusiastic yet unenlightened infrastructure developer might jump to is the establishment of a large-scale quadrilateral prism on the Cartesian plane, also known as a giant-ass box. This seemingly easy answer to a simple problem has its uses. It is extremely simple to construct and provides a large enclosed space for airships to park in. Additionally, implementing a system of small ground vehicles equipped with maintenance equipment to service and guide airships turns this cardboard box into a semi-functional hangar. That, unfortunately, though, is where the benefits end. Analyzing the efficiency of this design quickly yields several glaring problems. First is the obvious wasting of a huge amount of space due to irregular packing of airships inside an arbitrarily defined prison of concrete. A huge amount of the potential space is wasted by the extreme variance in airship sizes and shapes. Additionally, if an airship is too tall or too long, the entire hangar must be expanded just to fit the singular ship, resulting in increasingly devastating losses in efficiency. Therefore, this design should be used only as a temporary solution or specifically for airships of equal preferred sizes early on in, say, a survival service progression. After witnessing the failures of the gigantic box design, our prospective infrastructure engineer then settles on this modified design. Instead of having one giant box, instead let's have multiple smaller boxes stacked next to each other linearly. The engineer made sure to leave the front and back faces of the hangars open to compensate for length variation. They also raised the hangars off the ground to compensate for height variation and instead opted to secure the airships using sticker blocks or whatever other solution that extend towards the airships. An immediate advantage of this new alteration is that airships now have so-called designated parking slots, thereby partially eliminating the unorganized chaos of the giant hangar. Additionally, maintenance modules can be attached to the walls for greater and easier access to the airships. However, the size issue once again barges uninvited into the design, ironically finds no room for compensation, and consequently breaks everything once again. The main problem with this longer hangar design is the arbitrarily defined constraint on airship widths. Because the individual hangars are tiled next to each other, there is absolutely no tolerance room for any adjustments. This leads to the design failing spectacularly when it comes to certain situations. Let's look at this model. In this scaled down model, there are 3 hangars, each hangar being 2 blocks wide. The total available width of this hangar complex is 6. Over here, we have 3 quote-unquote airships seeking to dock in this complex, all with varying widths. The first one is 1 block wide, the next 2, and the last 3. In total, their widths add up to 6, perfectly matching the total available width of the hangar complex. However, because each hangar is 2 blocks wide, only 2 out of the 3 ships can actually dock. The first ship docks just fine, but leaves an entire block of wasted space in its hangar. The second one docks perfectly, and the third one cannot dock because the hangar is 2 blocks wide, and the last block of space was wasted on the smaller ship's hangar. Such is the dilemma caused by unregulated airship sizes, but since we can't make rules about how big people want their airships to be, we must think of other solutions. If only there was a way to borrow the otherwise wasted space from the smaller ship's hangar to compensate for larger vessels. Oh wait. In a brilliant moment of realization, the infrastructure engineer comes up with this design. Let's look at my mock-up docking complex. The hangar's default widths and divider heights were obviously scaled down for demonstration purposes. In the actual design, individual hangars will be likely around 25 blocks-ish wide by default. Each individual hangar is separated by these movable dividers, mounted on gantry shafts running along the length of the complex. Each divider also has one access platform attached to it, which is also movable via the same gantry carriage of the divider, which is done by powering the gantry shaft so that the carriage shaft starts spinning. In a previous design, I had two platforms, one on either side over here, but I realized that it is trivially easy for airship builders to just include doors on both sides of their ships, eliminating the need for two platforms compensating for the airship's orientation. The extra platform was just wasted space, so I discarded it. On each divider, you can attach maintenance modules, portable item interfaces, extra storage, and more. Additionally, each divider has a ladder for airship passengers to get from the hangars to the rest of the complex. Now, forgive me for performing a mumbo-jumbo, but the logic behind the gantry controls is actually relatively simple. This andesite casing portion basically interprets a signal strength from the analog lever and turns on a correlating redstone torch. It's currently set to 1. The output is run through the series of very basic logic gates that combine it with the manual input for controlling the clutches and the gear shifts. And finally, the gantry shafts themselves are also connected to the original output from the signal strength reader and another manual input by the combined into the logic gate so that we can turn on and off the gantry secondary feature of being powered. Oh, ignore that. That was an older design. Anyways, all of the rotation is sourced from this one block, so just simply attach one shaft connecting to it and you'll be able to power the entire mechanism. Now, let's do a bit of hangar configuring, shall we? Let's see. This is a channel select, or the hangar selection. This basically determines which hangar you're editing. Let's go with 4. Yes, right in the middle. This turns on and off the rotation of the main gantry. And this lever basically inverses the direction of it. So let's say in this space we need a larger area. We can just simply turn that lever on and then move it so that it is wider, and then we can just fit a smaller airship in that one, or if we want we can shift it over. Now, to edit the platforms, I have this lever so that when I flip it on, it's editing the dividers orientation, and if I flip it off, it now switches to the platform orientation, and you can see this one is now lit up because the redstone signal can pass through this line block now. And if we start moving it, you can see that it can go up and down. Very nice. And that is how you make a modular, tileable, dynamic airship docking complex. Now let's talk about limitations and shortcomings, which are always present with any and all designs and solutions. A major shortcoming is that the docking operator, in this case me, must communicate beforehand with all airships seeking to dock in the complex so they can properly calibrate the dividers accordingly and make sure that the total width of all the airships combined is less than or equal to the total available width of the docking complex. This means that a reservation system will likely be necessary for the docking complex to function well in a multiplayer environment. Think of it as like a private reserved parking slot for each and every airship. One limitation is that there can only be up to 15 of these modules, well technically 16, of these docks placed next to each other due to the signal strength reader maxing out at 15. This one has 8, but it's expandable outwards. You just tile this slice of the redstone over. Now, But wait a second, Soy, you ask. That's an arbitrary limitation that restricts the expandability of this design with no way of solving it. You hate those! And you will be absolutely correct, in most cases but not this one, because of render distance. In a fully scaled docking complex, dividers spaced 25 blocks apart times 15 equals a 375 block long complex. That's barely below Minecraft's default render distance limit. Or default render distance of like 8 chunks or so. Additionally, the docking control station must be positioned so that the operator can see all of the hangars, meaning that it is absolutely preposterous to even consider complexes with more than, say, like 8 hangars per module at max. This means that this limitation, in fact, is actually a helpful guide for any users of this design when implementing it into their own bases and airports. If you want more hangars, simply have a separate docking station for every 4 or 8 controllers, which not only improves visibility but also redundancy in case one of the docking operators fails. And that is all. Thank you so much for taking your precious time out of your day to listen to my extensive video essay on fictional infrastructure shenanigans, and I wish you the best in your future aeronautical endeavors.